Okay, when it comes to number 6 was coming from integration of specifically even powers. If you want to see the even powers and odd powers integration, please visit the playlist to see more. At the start of the video, you can see that question, you can pause the video and look at the question there. Now, this one, to handle it, you have to first expand this. So if I let this one to be my I, I'm going to have now my integral i's, integral from 0 to pi over 3 into, when you expand this we have, then plus cos squared 3y dy. Here now we know that whenever we have an even power of cos, we use an even power of geometric function, we use the double angle substitution for cos. So now we know that it's coming from whenever I have cos squared y, I have a half into 1 plus cos 2y. So when I double this angle, so now my cos squared 3y will be 1 over 2 into 1 plus cos 6y using the double angle substitution there. So this will be integral from 0 to pi over 3 into 1 plus 3y plus now I have now a half into cos 6y dy. So now if you integrate, here I'm getting y plus this one. When I integrate, of course, we get a positive of sine. So sine 3y. Then this will be now plus y over 2. Then plus 1 over 12 sine 6y. To integrating them from 0 to pi over 3. Then all we do is just have to substitute in the upper limit. Put in the upper limit there. I'll be having now pi over 3. When I put in the upper limit here, I have, when I put in pi over 3 here, I have pi. And sine of pi is 0, so plus 0. Then plus, here I have pi over 3 divided by this to give me pi over 6. Then plus sine, which will be sine 2 pi, which is 0. Then I subtract in, when I subtract in the lower limit, this will be 0 plus sine of 0 is 0 plus 0 plus 0 there. Okay, plus our 0 there. Sorry, 0 there, then 0 there, which is okay. 0 here, sine of 0 is 0, pi over 6, everything there seems to be okay. Which when I simplify, I'll be having 6. This will now be having pi over 3 plus pi over 6 surviving. Which when I simplify, I have 6 plus 3, which is 9, pi over 18, which will give me pi over 2. And that's how we simplify that number. So that was supposed to be our solution there. If you want, you can give this to 2 decimal places on your calculator, which if I press it on the calculator, my calculator should be in radians. So now I have pi, which is giving me 1.5708. This is 4 decimal places. Okay, when you come to number, our next number there was number 7, express. This is number 7. Wanted us to express 2 sine theta plus 3 cos theta in r sine theta plus alpha. Of course, alpha always has to be acute. Here, the easiest way, our r is always equaling to the square root of, you square 2 plus 3 squared, which will be giving us, this will be 4 plus 9, which will be root 13. Then always our alpha is equaling to tan inverse. alpha is equal to tan inverse of, it's in sine, then sine, it becomes a denominator. The coefficient of sine becomes a denominator. So it will be this over this. And so if you simplify that, you'll be having 56.31 degrees. So now meaning my r sine theta plus alpha is going to be equal to 2 sine theta plus 3 cos theta. But I have my r as root 13, then sine of theta plus alpha 56.31 degrees equals 2 sine theta plus 3 cos theta. And so from there, I've expressed this as in terms of this. So then we move to number 8, which was Maclaurin. So number 8, question 8. And now they want us to expand up to the power in x squared. You know that my f of x in Maclaurin is given by f of 0 plus x f prime of 0 over 1 factorial plus x squared f double prime of 0 over 2 factorial plus. If you want to see more about Maclaurin, visit the playlist there. Now we have to say, let my f of x be natural log of 2 plus x. I need its first derivative, so my f prime of x here is going to be differentiate this over the bracket, which when I take up, I have 2 plus x power negative 1. Because I want the second derivative, now my f double prime of x will be equal to 2. That will be negative 2 plus x power negative 2 into 1. As simple as that. So now remember, I have to evaluate each at 0. So f of 0 here, my f of 0, when I put in there is 0, have natural log of 2. And I put now f prime of 0 here. When I put in 0 here, remember this is equal to this. When I put in here 0, I have 2. 2 power this is now a half. When I come to this, when I put in 0 here, f double prime of 0, I have negative. This will be now 2 power negative, which will be negative a quarter. So here from here, my f of x, remember, we said our f of x is going to be now f of 0, which is natural log of 2, plus x into f prime of 0, which is a half, plus x squared, 2 factorial is 2, into now f prime double prime of 0, plus other terms. Always, if you don't include this, it means that your function is exact. So that's why you are going to be denied the marks. So you have to put the 3 dots always. So plus x over 2 minus x squared over 8 plus and other terms there. So that's how we do the number. But our function originally was this. So then I substitute for it back there. Minus x squared over 8 plus. So that's how we had to do number 6, 7, and 8. As simple as that. So that's section A. Let us now cross to section B.